This is Pre-Cal Lecture 7.3. If you'll wait to the end of the video, I will give you the solutions to homework 7.3, or the answers, so that you can ask me to work those that you miss when school reconvenes. You need to write these notes down for your notebook grade, and also so you'll have them for the final exam. So section 7.3.1 is solving systems with three variables. Okay, so I've just got a few vocab notes. A set of points satisfying a system of linear equations with three variables is the intersection of planes. So I'm talking about a geometric plane. So like a sheet of paper, something like that would be considered a plane. You've got three possibilities. First, we have an independent system So if you have an independent system, that means planes intersect at exactly one point. Okay? So that is mostly the kind of problem that we'll be working. A dependent system planes intersect in a line. Okay, and if that's the case, you'll have an infinite number of solutions. And I'll talk at the end of the lecture about how you know if you have a dependent system or this third one, which is an inconsistent system. So with an inconsistent system, the planes do not intersect. And in that case, you would have no solution. All right, so I'm going to work two examples of systems that have three variables. And hopefully you've done some of this before in your Algebra 2 class. All right, first example is, let's say we have x plus 2y minus z is equal to 1. The second equation, we have 2x minus y plus z is equal to 6. And our third equation, we have 2x minus y minus z is equal to 0. And we want to get a value for x, y, and z that satisfies all those equations. So if you have 3 equations and 3 unknowns, what you want to do is try to first eliminate one variable. And in this case, the easiest variable to eliminate is z, because it has no coefficient in front of it. So the first thing that I'm going to do is just add. So we'll call this, if you want, equation 1, equation 2, and equation 3. So I want to add equation 1 and equation 2. If you do that, you will eliminate z. So adding equation 1 and equation 2, we would have 3x, okay, because we have x plus 2x. And then 2y plus negative y would just give us plus y. The z's are eliminated, and then 1 plus 6 would be 7. Okay, so now I'm down to an equation with 2 variables. And now we can work with equations 2 and equation 3. So let's add equation 2 and equation 3. Okay, so 2x plus 2x would give us 4x. Negative y plus another negative y would give us negative 2y, so minus 2y. Z plus negative z eliminates z, and then you have 6 plus 0 is going to give us 6. Now at this point, we could use elimination to solve for x and y, or we could use substitution. I think in this case, it's really easy to use substitution. So I'm going to go ahead and rewrite this top equation solving for y. Y is equal to 7 minus 3x, and then I'm going to plug that in to this y right here. So I would have 4x minus 2 times 7 minus 3x is equal to 6. So again, I just plug 7 minus 3x into this y. And now we've got an equation that only has x's in it. Okay, so we'd have 4x minus 14 plus 6x is equal to 6. So we'd have 10x is equal to 20. So x is equal to 2. So we've got our first solution, x is equal to 2. Now it's really easy to get y because we've already solved for y up here. We know that y is equal to 7 minus 3x. So let's plug in 2 for x. Y is equal to 7 minus 3 times 2. That's 7 minus 6, which is 1. So we have our second solution. X is equal to 2, y is equal to 1. And then you just want to go back to the original 3 equations and solve one of those for z. I think the easiest one to solve for z is equation 2, but it doesn't matter. I'm going to rewrite equation 2 with z by itself and move 2x and negative y over to the right side. So z is equal to 6 minus 2x plus y. I just simply moved the 2x minus y, changed their sign, and moved it over to the right side of the equation. So z is equal to 6 minus 2. We know that x is 1. Plug that in. Excuse me, x is 2. Plus y is equal to 1. So z is equal to 6 minus 4. That's 2 plus 1, and that is 3. So the way that you need to show this solution is in a set of parentheses. X is 2, y is 1, z is 3. So when I give you an answer, that's how I will write it. X, y, and z, like that. All right, so that's our first example problem. If you're still writing, just go ahead and pause the video. I'm going to erase, and we'll do a second problem that's just a little more complicated. Okay, our second example, I'm going to use a lot of the board for this one. We have 3x minus 2y minus 2z is equal to 9. And we have x plus 4y plus 3z is equal to 5. 2x plus 5y plus 4z is equal to 8. So you get to pick whatever variable that you want to try to eliminate. But I usually pick one if I've got a variable that has no coefficient. That's typically the variable that I work with to try to eliminate. So in this case, we have x here in the second equation. So I'll go ahead and number these: equation 1, equation 2, and equation 3. I'm going to work with x. So the first thing that I can do is I can multiply equation 2 by 3. And then I can subtract it from equation 1 and we can get rid of x. So if we multiply equation 2 by 3, what you have is 3x plus 4y, plus 12y plus 9z is equal to 15. And I'm just going to move equation 1 over here, and we'll have 3x minus 2y minus 2z is equal to 9. And so I can get rid of x by subtracting the second equation from the first equation. So I like to put it in parentheses to make sure that I distribute that negative sign. So 3x minus 3x eliminates x. Negative 2 minus 12 would be minus 14y. Negative 2 minus 9 is minus 11z. And then 9 minus 15 would be negative 6. So I'm going to hold off on that, but I now have an equation with just two unknowns. So I need to eliminate x again. Okay? I'm still going to work with equation 2. So this second time around, I'm going to multiply equation 2 by 2. And then I can subtract equation 3. Okay, so we're going to multiply equation 2 by 2. That would give us 2x plus 8y plus 6z is equal to 10. And then I'm going to rewrite equation 3 right underneath. So I have 2x plus 5y plus 4z is equal to 8. Now I'm going to subtract equation 3 from equation 2. Okay, so again, I multiplied equation 2 by 2 so that I have the same coefficient as the x in front of equation 3. Subtracting equation 3, the x's are eliminated. 8y minus 5y would give 3y. 6z minus 4z would be plus 2z. And then 10 minus 8 is 2. So now I've got a second equation. Now in the first example I used substitution. It was pretty easy to do because our y didn't have a coefficient in front of it. Now I'm going to rewrite 3y plus 2z is equal to 2 right underneath our first equation that we got. And I'm going to use elimination this time to solve for one of the variables. And you could work either with y or with z. I'm going to work with z. And what I'm going to do is I'm going to multiply this first one by 2. And I'm going to multiply the second equation by 11. Okay, so I multiplied the first equation by this coefficient and the second equation by that coefficient. That's going to allow me to add the two together and eliminate z. Okay, so we'll multiply by 2, and then we're going to multiply the bottom by 11. Let's do that and rewrite. So I've got a minus 28y minus 22z is equal to negative 12. And then the second equation by 11, 33y plus 22z is equal to 22. And now I can add those two equations together, and that will eliminate the z. Negative 28 plus 33 is 5y. The z's go away. Negative 12 plus 22 is 10. So finally we've got an answer for y. Y is equal to 2. Now it's pretty easy to solve for z if I just use this equation right here. 2z is equal to 2 minus 3y. I just rearranged this equation. And now I'm going to plug in y. So 2z is equal to 2 minus 3 times 2. We know that y is 2 from right here. All right, so 2z is equal to negative 4. So z is equal to negative 2. So now I've got a second answer. All right, now I can get x, and I'm going to work with equation 2. That's the easiest one to solve for x. I'm just going to shoot the 4y and the 3z over to the right side. So we'll have x is equal to 5 minus 4y minus 3z. So x is equal to 5 minus 4 times y is 2 minus 3, z is negative 2. So x is equal to 5 minus 8 plus 6, it's negative 3 plus 6 is 3. So we have our third solution. So I'm just going to write this as 3, 2, and negative 2. You can check that by plugging those solutions back into the original equations and make sure that they work. All right, if you're still writing, you might want to pause the video to finish writing all that down. I'm going to erase and just give you a couple of sentences to tell you what to do if a system is inconsistent. All right, if a system of equations is inconsistent, we talked about this at the beginning of this lecture. A false statement will occur somewhere in the solution process. So an example of that, let's say you've done some elimination and you eliminate a variable and you end up getting something like 0 is equal to 3. When you add or subtract the two equations. Okay, so if you get a false statement that's an inconsistent system, that's a no solution situation. Right? If a system is dependent, so this was the other one. A system is dependent, you will get two equations, or really what you will get a true statement. You'll get a true statement such as 0 equals 0 along the way. So all your variables go away and you just get one number equals the same number. Okay? All right, so that means there's infinite number of solutions. Okay, so that is the entirety of a lecture 7.3. I'm going to go ahead and give you the answers to the homework problems. There's only 3, but they do take up quite a bit of space. So the answer to number 1 is -3, -2, and 5. The answer to number 2 is 3, 1/2, and -1/3. And the answer to number 3 is -1, 2, and 5. So give those a try, show all your work. If you can't get one of them to work out, you're not sure what you're doing wrong, when classes reconvene, just make a note that you want me to work that one in class, and I will. So that concludes Pre-Cal Lecture 7.3.